Good evening, sir.
Are you getting my voice? Good evening.
Yes, sir.
Hello, Divyangi and Hiba, both of you.
Sir.
So, okay. So in the last class, I have discussed first what is angular displacement and angular velocity. Two things I have discussed. Angular displacement is basically uh, the angle uh, subtended. Okay. This is a person A moving in a circular path, and you are observing the motion of this person from here. And this person is moving in this direction from A to B. So in going from A to B, the angle make or made by this person is basically the angular displacement. And we measure the angular displacement either in degree or in radian. Radian is the SI unit, and this angular displacement is an axial vector. And how to find the direction of uh, angular displacement? Right hand thumb rule. Okay, and there is a relation between the distance and the angular displacement, that is theta is equal to arc upon radius. These things I have discussed in the last class. What is angular velocity? Basically angular velocity like linear velocity, linear displacement divided by time. Angular velocity is angular displacement divided by time. So we measure the angular velocity in two ways: average angular velocity and the instantaneous angular velocity. Average means for a period of time, we calculate the angular velocity, that is average angular velocity. So for example, suppose a person is moving for 0 to 2 seconds. For 0 to 2 seconds, if someone is asking what is the angular velocity, in that case, you will tell that person the average angular velocity. If someone is asking what is the angular velocity at t is equal to 2 seconds, means he or she want to ask the uh, instantaneous angular velocity. So instantaneous angular velocity means angular velocity at that instant of time. This is also the axial vector, and direction is given by right hand thumb rule. I have discussed this in the last class. So basically this is the difference between linear and the angular velocity. You can see here angular velocity, angular displacement divided by time. Linear velocity is linear displacement divided by time. Divyangi and Hiva, is my voice okay now?
Yes, sir.
Okay. So this is the angular velocity. Basically, compare both the motions, linear motion and circular motion. Now we are studying the circular motion. So in circular motion, things will be different. So analogy will help you. Okay, analogy will help you. So like linear velocity is displacement divided by time. Okay, linear displacement is also known as linear displacement. Okay, angular velocity is angular displacement divided by time. This is an axial vector, this is a polar vector, and direction is given by right hand thumb rule. This direction is simple. Okay, unit radian per second, unit meter per second. Average angular velocity is delta, sorry, average velocity is delta s by delta t. Delta s by delta t, total displacement divided by total time. Average angular velocity is delta theta by delta t. Okay, instantaneous velocity is ds by dt. Okay, differential form. And instantaneous angular velocity is d theta by dt. So we will solve one question on this. This is the question. Theta is given as, basically this theta is given as 2t square plus 2. Find angular velocity in 2 seconds. And at 2 seconds, they are asking. In 2 seconds and at 2 seconds, we have to find the angular velocity. So theta is given. So basically this theta is variable. With time the theta will change. You will put different value of the time, you will get different value of theta. Means with time the theta is changing, and change of theta with time is angular velocity. And we can measure the angular velocity in two ways, either instantaneous or average angular velocity. First they are asking find angular velocity in 2 seconds. In 2 seconds means there is a time period, there is a definite time period in 2 seconds. 0 to 2 seconds they are asking. Okay, it means 0 to 2 seconds. 0 to 2 seconds. So first you will calculate the average angular velocity, and average angular velocity is given by delta theta by delta t. Okay. Delta theta by delta t. What is the meaning of delta theta? Change in theta. Change in theta, you can write it theta 2 minus theta 1. Theta 2 means this is theta at T2 and this is theta at T1. What is T2? T2 is this and this is your T1. Starting time is T1, finishing time is T2. So T1 to T2 you have to find the angular velocity. So now first find theta 2. Theta 2 means in this equation you will put simply T2, value of T2. Okay, so means at T is equal to 2 second you have to find, and that will be your theta 2. So it will 2 into 2 square plus 2. So it will become 10 radian because the angle of theta is radian. Now theta 1. Theta 1 will be 0 because T1 will be 0. So at T is equal to 0 you have to find. T is equal to 0 you have to find. So it will be 2 into 0 square plus 2. So basically it will be 2 radian only. Now what is delta T? Delta T is basically you can write delta T is equal to T2 minus T1, that is equal to 2 minus 0, 2 seconds. Now average angular velocity is delta theta by delta T. So what is delta theta? That is delta theta is change in theta. Delta theta is change in theta. Theta 2 minus theta 1. T2 minus T1. So what is theta 2? Theta 2 is 10 minus 2. It is 2 minus 0 is 2. It is 5 by 2. Okay. It will become 2.5 radian per second. Okay. Oh, this is 10 minus 2. Sorry, what I am doing. So sorry. This is 10 minus 2 will be 8 divided by 2, and this is 4 radian per second. Radian per second is the unit of angular velocity. In the next, they are asking at t is equal to 2 seconds. At 2 seconds. So basically, here you have to find instantaneous angular velocity d theta by dt. So you can write dy dt, and theta is 2t square plus 2. Can you do the differentiation? Hiva and Dibyangi, can you do this differentiation? Okay. So differentiation of 2t square will become 4t, and differentiation of 2 will be 0. And here you will put t is equal to 2. So basically you will get 4 into 2, 8 radian per second. 8 radian per second you will get. Got it, Divyangi and Hiva?
Yes, sir.
Hiva, got it?
Yes, sir.
So differentiation already I have told you. Okay. Okay, there is a relation between the linear and the angular velocity. There is a relation between the linear and the angular velocity. First, we will discuss this relation with the for the circular motion. So this is a circle, and center of the circle is this. and a body is a particle is there, this and this particle is moving in a circular path, and this is the radius of the circle. So at this point, the direction of the linear velocity will be this, tangent to the point P or particle P. If here is the particle, then direction of the velocity will be in this direction. Okay, tangent to the point. This will be the velocity V. This is also the radius. So in case of circular motion, in case of the circular motion, you can see radius and velocity are perpendicular. Radius and velocity are perpendicular. So basically this person is moving with an angular velocity of omega. Not this person, this is a particle P. Particle is moving in a circular path with an angular velocity of omega. So for the linear speed, you have to draw a tangent at this point. If you want to suppose calculate the linear speed of this particle at this point, and this particle is moving in anti-clockwise direction like this. So what you will do, along the sense of the direction of the motion, you will draw the tangent like this. So here this will be the direction of the linear velocity of the particle, and this will be the radius. So in case of circle, this is a tangent, and tangent is always perpendicular to the radius, always perpendicular to the radius. Okay. In case of circle, basically in case of circle, there is a very famous relation, V is equal to R omega. V is equal to R omega. This is valid in case of the circular motion. What is V? V is the linear speed. R is the radius of the circle, and omega is the angular speed. Okay. This is valid in case of the circular motion. But in actual, what happens? Basically, relation between the linear velocity is equal to R into omega cross R. This is a cross product. This will be omega cross R vector. So this is the actual relation, and from this relation, omega, when you will find now, when in question omega, so always write omega is the velocity perpendicular to the radius divided by the radius. V perpendicular is the velocity perpendicular to radius. Velocity perpendicular to radius, and R is the radius. Okay, so these relations are always valid, but this relation is valid only and only in case of the circular motion. And remember that if someone is saying I can write V is equal to R into omega, this is wrong. Why? Because direction of velocity is different and direction of omega will be different. You can see here that velocity is in this direction and omega will be towards you by the right hand thumb rule. Okay, so this relation will be not valid. So in case of circle, the linear velocity is always perpendicular to the radius. Okay, so here we can write, in case of circle, linear velocity is always perpendicular to radius of the path or radius of the circular path. So this is only true for circular motion. So now you can see here at different points, at different. I will discuss this once again when I will discuss the acceleration. So at different points, this particle is moving like this. At different points, the direction of the linear velocity is changing in case of the circular motion. And in circular motion, the linear velocity is always perpendicular to the radius. So that is why we can write this v is equal to r omega, or from here you can use this with the help of this also you can write omega is equal to v perpendicular by r. When you will calculate omega, so v perpendicular is here is this v is the v perpendicular basically, and divided by the radius r. Okay, okay, Hiva and Dibyangi.
Yes.
So
Yes.
basically this is always valid. So don't confuse in this. We will solve the questions after this. And this is not true. Okay, so first I think you should write down the should write down this part fast. Then we will solve the question. So Divyangi, basically this is just the starting of this chapter. Okay. So in the last class, I have just told what is the angular displacement and the angular velocity. Nothing else. Okay. Copy this question also and answer. Hiba completed? Divyangi completed?
Yes, sir.
Hiba?
So 1 second.
Okay, okay. Fine. So in when the particle on the or when the body is moving in a circular path, okay, circular path can be like this also. We will also study the vertical circular motion, horizontal circular motion. So in any type of circular path, like you can see, the Earth revolves the sun in a circular orbit. So in that case also, V is equal to R omega is valid. In most of the cases, V is equal to R omega is valid. Why this is valid? Because in that case, the direction of the linear velocity or linear velocity is perpendicular to the radius of the path. Okay. And how to find the direction of the linear velocity when a body is moving in a circular path? Okay. At the location of the body, draw a tangent to that circle along the sense of the motion. Whether the body is moving in an anti-clockwise direction or clockwise direction. There can be two direction in of motion in a circular path. Done. Okay, very good. So this relation is very, very important, and please write down this also. So P is the particle, and this particle is performing the circular motion. This particle is performing the circular motion. Okay. So basically here I have written this velocity. Now I am talking about the magnitude of the velocity. Okay. So magnitude of the velocity is basically the speed. Now you have to focus on this particle P. Basically, you are observing the motion of this particle from the center. Okay, you are here. Observer is here. So you are observing the motion of this particle. So in the circular motion, keep in mind this point that you are observing, or observer is observing the motion of the particle or the body which is moving in a circular path from the center. Then also, he or she will find that the particle is moving in a circular path like this. So we are just discussing the velocity only, okay? Not the acceleration. I will discuss after the velocity. We are discussing what is the velocity in the circular motion. So in a circular motion, one is the linear velocity. Linear velocity is there. So if the motion is the circular, so linear velocity at different points will be different. Okay. And for the direction, you will just draw the tangent. And why I am saying at different point, the velocity will be different. This point you will get to know when we will discuss the acceleration. So in case of the circular motion, even if the speed is constant, then also the velocity will always change. Completed, Hiba?
Yes, sir.
Okay, now we will solve the question. This first question. This is the point O, and this is a particle P initially here, and this particle P is moving in this direction. Okay, P is moving in this direction with a velocity of, I think, 4 meter per second, 10 meter per second. Sorry, this is moving with 10 meter per second. Okay. At point A, when this particle is moving like this. Okay. And at point A, this particle P is the particle. This particle P have the velocity of 10 meter per second. At point B also, this particle has the velocity of 10 meter per second. Okay. Okay. Now, so don't think that angular velocity is only the property of the circular motion. Okay. Not only in circular motion we have the angular velocity. Here also you will see that we will calculate the angular velocity. So they are asking in first case, angular velocity of point P of particle P with respect to O, when it is at A, So now you will apply this general formula. Omega is equal to V perpendicular divided by R. This is always valid. V perpendicular. What is the meaning of the V perpendicular? Perpendicular velocity perpendicular to the distance or radius with respect to the point. You can say. Now they are asking from this point O. So here in this case, this will be your radius. This will be your R. That is 4 meter. What you are finding in first part, you are finding the angular velocity of point A with respect to this point O. One point will be given always. Okay. With respect to some point, you have to calculate the angular velocity. So with respect to O, this time radius is this or R is this, and what is the velocity perpendicular to R? 10 centimeter. So it will be 10 centimeter. 10 by 4 radian per second. will be your answer. This is first answer. Now second part. They are asking angular velocity of particle P with respect to with respect to this point O when it is at B. Now, when the particle reaches at B, in this case, you have to find the angular velocity. So you will apply this formula: omega is equal to velocity perpendicular to the radius divided by the radius, or velocity perpendicular to the distance divided by the distance with respect to the point. Okay. Now, with respect to this point O, what is the distance between the point O and B? 5 meters. So here you will write 5. But you have to find a velocity which is perpendicular to this distance, or the OP, OB, na? This is a point B. So I am writing here, this is B. This is a particle P. So this, but the velocity is in this direction and you want the velocity perpendicular to this OB. So basically this velocity is required. This velocity is required. So for this, suppose this angle will be given to you. Uh, mm, this angle is given as 37 degree is given. So initially it will be given to you in the question. So this angle will be 37 degree. So we can find this angle. Okay. So you can see you have to just draw some, do some construction basically. So when you will find this line and this line is parallel, so this angle will also be 37 degree. Okay, this angle will also be 37 degree and this angle will also be 37 degree. Okay, in another way also you can find this angle. In another way also you can find this angle. How? See, if you will draw a horizontal, na, so this angle you will get 53 degree. Okay, because this is 37, so you will get this angle as 53 degree. Now this is a line and this line and this velocity are perpendicular. So basically this angle will be 53 degree and this line and this velocity are perpendicular, means angle is 90 degree. So this angle will be basically 37 degree. So basically you have to take the component of this 10, okay, in this direction. So Divyangi, can you tell me what will be the component of this 10 meter per second along this direction, which is perpendicular to the distance OB? Ten cos 37. Very good. 10 cos 37. It will be 10 cos 37. Basically, this thing we want to find now. B perpendicular. This is B perpendicular. What is the meaning of B perpendicular? Velocity perpendicular to the distance. Okay. So B perpendicular here is 10 cos 37. So how can you find the cos 37? I have told you there is a triangle having angle of 37 degree, 3, 4, 5. So from here you can find cos 37 degree. That will be 4 by 5. Okay. So it will be 4 by 5 into 5. It will become 4 by 25 and omega radian per second. Omega can write in radian per second. Okay, so next question. Next is this question. So I think this distance is given as 4 meters. there is a particle at this point P, at this point a particle, and this particle have the velocity 5 meter per second, and this is O. We have to find the omega of particle P with respect to O. Omega means angular velocity. So what you will do here, you will just apply the simple omega is equal to V perpendicular, velocity perpendicular to the distance divided by the distance. Okay, or you can say R simply. So V perpendicular is required, and this is the distance. So perpendicular to distance means this velocity in this direction is required. So in this direction the velocity is required. So see how we will find it. Basically we have to find the angle. Okay, so what you will do here in this case, this distance is 4 meter. This is 4 meter given, so you can write here. So what you will do here, you will draw like this, and this angle will be 53 degree, not 53 degree. Uh, this line and this line parallel, so this angle will be 53 degree. This angle will be 53 degree. Okay, this angle will be 53 degree, and this whole angle, this distance OP and this direction is perpendicular, so whole angle is 93 degree, 90 degree, so this angle will be 37 degree. So basically you will get uh, the velocity in this direction. Okay, velocity in this direction with the help of this angle. So now you can see this angle also will become 53 degree, this angle will become 53 degree. Okay, so basically here the velocity will be 5 into cos 53. Okay, so you can remove this, you can do this. Okay, you can find the angle. Basically this angle you want na, because you want to find the velocity in this direction, that will be 5 cos 53 degree, and distance is 4, so B perpendicular is 5 cos 53 degree divided by the distance 4. So basically this will be your answer in this case. This will be your answer in this case. Okay, so cos 53 you can find. Okay, write down. Dibyangi and Hiva, in your schools, have you completed the work power energy?
Yes, sir.
Okay, then it's fine. Completed. Okay. Hiva also completed. You also completed.
Yes, sir. Yes.
Okay. Okay. Write down this question and answer first. Then we will solve one very interesting question. Oh shit. Completed.
Yes, sir.
Okay. Now see this question. Basically, here it is given that a particle or a projectile is thrown with a velocity of 10 meter per second and making an angle 30 degree with the horizontal or the ground, you can say. So you have to find omega. Omega means the angular velocity of the particle p with respect to this point o, with respect to this point o, before hitting the ground, before hitting the ground, or you can say just reaching to the ground. So this particle will be here before hitting the ground. Okay, this here. So what will be the velocity here? Linear velocity. Completed the na work power energy. Okay. So you know conservation of mechanical energy? Hmm? Conservation of mechanical energy means energy at this point P is equal to the energy at this point. Suppose at point Q the this particle is finally the particle is at point Q. So energy at point P is equal to the energy at point Q. So with the help of that we can find the velocity at this point. Okay, so at this point what type of energy this particle will have? If I am just supposing this as this ground as a reference point, so here will be only the kinetic energy. So I am saying kinetic energy plus potential energy at point P is equal to the kinetic energy plus potential energy at point Q. Conservation of mechanical energy we can apply because there is no friction. Okay, there is no friction force. In case of projectile, I have told you air resistance is neglected. Okay, So kinetic energy at point P will be half into mass of the particle into velocity of the particle, speed of the particle, that is 10 square. Potential energy will be 0 because I have just considered this ground as the reference. Okay, I am just taking the help that you have completed the conservation of mechanical energy and in work power energy. I will tell you when I will start that chapter. But directly, I don't want to say that this velocity will be here also 10 meter per second. So now at point Q, there will be only kinetic energy, that will be half into mass of the particle into velocity at Q square, and potential energy will be again 0 because the particle will be again at the reference point. So from here you will get the velocity of Q. Velocity at point Q is equal to again 10 meter per second. Okay, 10 meter per second you will get. And this angle will be 30 degree. Okay, this angle will be 30 degree. Okay, you can calculate by using the equations. Okay, this angle will be 30 degree. How you will calculate this angle? Okay, let me tell you what you will do. You will take the component of this in this direction, that will be 10 cos 30, that will be 10 cos 30 degree. So the horizontal component does not change in the projectile motion, it will be 10 cos 30. Okay, and you will take one component in this direction, that will be 10 sin 30 degree. So if you want to find this angle, suppose initially I do not know this angle. Okay, so how I will find? It will be what I have told you, tan theta is equal to velocity in y direction divided by the velocity in x direction. So this theta you want to find. So velocity in y direction is equal to 10 sin 30. So tan theta is equal to 10 of sin 30 divided by 10 of cos 30. Cos 30. So it will be tan theta is equal to 10 and 10 will be cancel out. Sin 30 is 1 by 2. Cos 30 is root 3 by 2. So 2 by root 3 it will be. Okay, so 2 and 2 will be cancel out. Tan theta you will get 1 by root 3. Okay, tan theta you will get 1 by root 3, and at what theta? Tan theta is 1 by root 3, theta is equal to 30 degree. Okay, so this angle will be 30 degree. And you can learn also this thing. If you are just showing a projectile from some point, so initial velocity will be the final velocity. By the energy conservation, and angle will also be same by the symmetry, you can see. So now coming to the question, they are asking the angular velocity of the particle P with respect to O before hitting the ground. What is the angular velocity? Perpendicular to the distance, velocity perpendicular to the distance divided by the distance, that is r. So in this case, this distance PQ will be the r distance. Okay, this PQ distance will be the r distance because you have to find the angular velocity with respect to this point O. Okay, so this distance will be the PQ distance. And what is PQ distance? PQ is basically the range of the projectile, range of the projectile. Okay, and perpendicular to this range or this distance, this is the velocity, that is 10 sin 30 degree. So PQ is basically the range. Okay, so PQ is basically the range, and what is the range? How we calculate the range? U square sin 2 theta divided by g. U square means 10 square, and it will become sin 60 divided by, take the value of g as 10. So you will get from here the value of PQ, and when you will put the value of PQ here, 10 sin 30 will become 5 and it will be PQ. When you will put value of PQ here, you will get angular velocity. So 5 divided by PQ will be your answer. Okay, 5 divided by PQ, or you can write here range also. This question is, I will say, good question. Okay, note down fast. Got it, Hiba and Dibyangi?
Yes, sir.
Yes, sir.
So with the help of this conservation of mechanical energy, we can find the velocity. Okay, and this distance, we know this is known as the range of the projectile. So we will apply the formula of the range and we will calculate this distance. And perpendicular to this distance will be the perpendicular velocity. And omega is b perpendicular divided by the distance. So in next class, I will start the acceleration in the circular motion. So please don't miss the next class. And next class is most important class. Next class and next to next class is the most important. If you are not able to understand the acceleration concept in the circular motion and the force concept in the circular motion, you will not understand the further chapters in a proper manner. Okay, whenever there will be a question related to the rotational motion, related to the circular motion, you will always have doubt. Okay, if you will not understand that properly. In the next lecture, we will discuss the type of acceleration in the circular motion, and next to next lecture, I will discuss a very important force, that is centripetal force. That is very important. So don't miss the next class. Completed?
Yes,
Yes.
sir.
Okay, so if completed, then tell me the answer of this question. Where is the question? Just tell me what option will be correct. Will be the correct. Fast. You have 1 minute only. Which option can be correct? It is a multiple choice question. Hmm. Hiba, better tell me.
Yes, sir.
Can
D
you?
option.
Hmm?
The
D.
D option.
Yeah, right. Any other? This is also valid, na? This option. And I have told you that this is only valid for circular motion. So this will be not correct. But this is correct only for circular motion.